We're also told that Earth has multiple wobbles and that Earth revolves around the sun, actually in a state of free fall at over 66,000 miles per hour, and that Earth is moving around the Milky Way galaxy at over 500,000 miles an hour, and it's expanding outward in this expanding universe, expanding into who knows what, but it's happening at over 1 million miles per hour. So everyone listening to this or watching this right now is moving in all of those ways, and yet we feel nothing.
Hi, and welcome back to Reclamation Radio. I am Dr. Kelly Brogan, and today's guest, Mark Gober, is an esteemed colleague, a brilliant author. We're going to be focusing on his 7th book today, which is called An End to the Upside Down Cosmos. And here are some of the tidbits you will be enjoying. Number 1, why the shape of the Earth matters and what the journey from globe believer to globe skeptic can look like. 2, the many reasons that we do not actually live on a spinning globe. And number 3, rethinking the Big Bang solar system, where we live, and how it feels to shift out of the indoctrination and programming on this subject. It's a little spicy, and I aim to deliver you in about an hour the nuts and bolts of inquiry into this essential topic. Welcome, Mark, to the show.
Kelly, thank you so much for having me.
So you are a return guest, and today I want to focus on your latest opus, which is called An End to the Upside Down Cosmos. So for those listening who don't know, you have birthed, and I would bet lots of money that you will continue to do so, a series that follows this name. And I was so delighted to learn that you were going to focus your expert lens on this subject, on the subject of cosmology. And I want to start out by talking a little bit about your journey into this intellectual terrain, because your books cover like a huge spectrum of topics that all have in common this thread of deep inquiry, of sovereignty, and sourcing, if I could say, a connection with, a kind of consciousness that restores meaning, right, to this human experience. And this subject for many is a blind spot, right? In fact, I'm sure you've heard, and maybe even you were this person, I was this person. I still remember being on an interview with David Avocado Wolf, and this is a couple of years ago. And he started talking about how in Hawaii, you can see like one island from another island that you shouldn't be able to see because of the curvature, supposed curvature of the Earth. And that, debunks the globe. And I remember sitting there thinking, who cares? Like, why are we talking about this? This is so ridiculous and irrelevant. I remember having that feeling of almost like a kind of projected embarrassment, interestingly. And of course, I fell down the rabbit hole myself, as I've shared in 2020, because I had a friend who really, she was like an angel. And she like dropped into my life and dropped out and like popped out. And she came in around the time I was crystallizing my understanding of what was going on, of course, in 2020, having been one of us who was preparing for what seemed to finally materialize for many, many years. And, we were talking about the George Floyd event, and she was sending me all of these handles on Instagram that had like, there's no curve, bro, or whatever. Like the handles were all these like flat earth related handles. And I was like, why, Esther, why are you sending me these like flat earth accounts? This is so bizarre. Like, why are they all seemingly promoting this perspective on cosmology? And again, I just didn't see the relevance of it. And remember, she said to me, and I have an interview with her in my sovereignty series, but remember, she said to me, are you ready to go down the biggest rabbit hole there is? And, 10,000 hours later of research. I mean, I just hundreds of hours I just consumed. But it took me the better part of a year and a half to really make sense out of it. And as I was sharing this with my friends, I said, it's the same exact thing as medicine, as education, as finance. It has the same structure. The awakening feels similarly delightful, right? So I always like to say that, if it doesn't feel good, it's not the truth, right? Like you're not there yet. And there's something that just feels so orienting to this subject matter. So when our mutual friend, Melly, reached out to me and she said, I'm talking to Mark and he's asking a bit about cosmology and, I don't remember exactly, you can tell me how it came up, but I keep this like little document, with some like links and some of the ways that I have thought about this subject and deconstructed so many aspects of what I formerly believed and all of the sort of like spin-off subjects like, evolution and dinosaurs and satellites. And I shared it with you. It was literally, a month and a half? I mean, it was such a short period of time that I learned you had produced this book. Okay, we're going to talk about this book, and this conversation is going to be less of me doing this, talking and yapping the whole time, and more of you pretty much teaching, because I want this interview to stand on its own as an invitation to anybody who feels that little tickle inside that wants to just have a one-stop shop, wants to say, okay, tell me what the deal is, right? And meanwhile, most of us spend many, many hundreds of hours, if not thousands, exploring this subject because it just keeps going and keeps going and keeps going. But you produced this book, you channeled it. I can't explain it any other way because it was such a short period of time that you went from, and I'm going to ask you to tell your side of the story, that you went from being, I would say, like a conventional thinker, no offense, in the realm of cosmology, and such a radical thinker in all of these other domains. Okay. So I would call that a blind spot. We all have them. I'm sure I have many still remaining. And that you came to the same conclusions that I've come to after, it was probably like, again, a year or two of research and speaking to others and really digging into this topic. And I consider this book, An End to the Upside Down Cosmos, the definitive resource right now that is available on this subject. And it is so welcome. It is so something to celebrate because I'm a big believer that handing somebody a book that acts as a portal to another way of thinking, to a more expanded reality, is one of the greatest gifts that we can provide each other as humans. So I would love, Mark, to hear a bit about your journey into this world from, no pun intended, from skeptic to, I would say a more free thinker. And really, what were some of the sacred cows that had to die, right? Because I didn't interact with you directly about it, and I don't know how hysterical you were about the prospect of thinking differently, but in my experience, and I don't know why this seems to be in some way a sexed matter, but in my experience, men can really get their panties in a bunch about this subject. And I don't know what it is. I have my theories about father woundology and all the things, but it can really set people off, especially in our realm of truthers and people who, I don't know, I guess we can play a bit like know-it-all, right? So I wonder if there was like a lot of emotional resistance, what came up, and sort of how you walked your way into the conviction that it was time to write a book about cosmology.
Well, thank you for that preface, Kelly. Let me start with my journey, like you were suggesting, and then maybe we can move into the details of what was swaying me. But let me take you way back because this is my 7th book. And so I've looked at many paradigms and have had to rethink life in so many different ways over the past number of years. But I was, like you said, a very conventional thinker. I went to Princeton for undergrad. I worked in investment banking in New York. During the financial crisis, I was at UBS, one of the big investment banks. And then I worked in Silicon Valley for about 10 years advising technology-focused companies. And while I was working in Silicon Valley, I started listening to podcasts. And at the time, I would have called myself maybe an atheist or agnostic. I wasn't even looking at the nature of reality. I thought life was random and meaningless. I was totally there. And then I heard podcasts that made me question that. Basically, podcasts on the nature of consciousness and whether consciousness is something that comes out of our brain or whether our brain is like an antenna receiver or some kind of an interface for a consciousness that's well beyond the body. And if the latter is true, then that means there might be a soul and maybe our consciousness continues when the body dies. This for me was the biggest worldview shift of all, because going from when you die, that's the end, to wait, maybe when you die, there's more, and maybe there was something before your life, and there's all the stuff that we have amnesia to. Whoa, I have to rethink all of existence. So that was my first book, An End to Upside Down Thinking, was published in 2018 after I just became obsessed with this topic of consciousness. And then I decided to leave my firm, actually right before everything happened with COVID. And I wrote a second book, An End to Upside Down Living, which is about basically how you think about living life with this new perspective on consciousness. Interestingly, on the cover of that book is a globe. Even though I wasn't talking about cosmology, it was just, I don't know, it was just like kind of the symbol of interconnectivity. So I wasn't trying to make a point about it. It was just not a paradigm I had explored at the time. And since then, since having left my job, I've written on a number of topics. So voluntarism, An End to Upside Down Liberty, we spoke about that previously. An End to Upside Down Contact, on the UFO contact phenomenon, and just contact in a metaphysical sense too, like in a near-death experience or psychedelics. And then I wrote about the Great Reset. And then I wrote about An End to Upside Down Medicine, which challenged germ theory. And while the other books relate to cosmology in some ways, in terms of the paradigm shifting elements, I think the medical topics are very similar to the cosmology topics in terms of the logical fallacies that we see, which I'll get into. But what I noticed after writing the book on medicine, and let me take a few steps back, because I had heard people talk about whether or not viruses exist starting in early 2020. And at the time, I wasn't looking at government conspiracies or anything. I wasn't close to it. I just had never looked at this sort of thing. And I remember hearing people talk about, well, yeah, SARS-CoV-2 doesn't even exist as a virus. I was like, well, that's interesting, but they're talking really technical stuff about methodologies, and I would need a lot of time to evaluate what they're saying. And it wasn't until 2023 that I actually looked into it, and I realized there was a lot of important information regarding just basically the history of medicine that many people weren't talking about, and methodological problems. And there was this group of people who went really deep, and they made great points, and I decided, okay, I'm going to write a book about this. And I found that many of those same people were asking the same questions about cosmology, basically taking the same logical problems that we see in medicine, basically where people jump to a conclusion about why something happens and they get stuck in that model. They were saying the same things true about cosmology. So I had in the back of my mind, okay, these are people I respect and they're looking at cosmology. I haven't looked into it. I'm not close to it, but I haven't looked into it. I mean, I had heard Dave Weiss, who's one of probably the biggest voices, talk about flat Earth, probably 2021 or 2022. I heard him on a podcast and I said, this is really interesting, but I would need a lot of time to explore this. So I just got sidetracked with other things. The medicine book came out in end of 2023, and I usually take a few months break after a book. And I went to a conference called Confluence in Texas, run by Alex Zeck and his colleagues. And actually, right before Confluence, this is April of 2024, Steve Young's book came out, A Fool's Wisdom. He's a theoretical physics PhD. And everyone was talking about it, so I got it on Kindle, and I was looking at what he was saying about Earth. And so I was interested because he, as a theoretical physics PhD, said, look, I'm not sure with 100% certainty what Earth is, but I know with 100% certainty it's not a spinning globe. And I said, okay, what's going on here? Because now I have a lot of people who seem pretty credible who spend time on this and they're unable to basically validate the spinning globe model. So I'm sitting at Confluence and the topic of cosmology kept coming up everywhere. And the last day of the conference, I remember sitting with Melly and also Yerasimos, who co-hosts Here for the Truth. And we're having this conversation about cosmology because it was coming up everywhere. And the conversation was sort of like, well, why does this really matter? Like, why are people so up in arms? Maybe it's not a spinning globe, but like, I still have to go to work and take care of things. So I guess my interest had been piqued at the time. And then Melly started to nudge me and she sent me the resources that you had put together. And I went through those in, I don't know, like 2 days or something, plus or minus. I just spent all day like on 2x speed, listening to everything that was there. So that was an amazing platform that you provided, Kelly. Thank you for that. And you're in the acknowledgments of my book because it was really, really helpful. Then it gave me a lay of the land of like who's saying what are the basic categories that I need to look into. And then I do what I always tend to do when I get interested in something is that I buy every book I can find on the topic. I just go on Amazon, order everything. And I find every lecture I can and listen to as much as I can, basically. And then I get to a point where I feel like I've heard maybe not everything, but the general categories are all there. And the rest is history, I guess. I become obsessed and I can't stop until it's done. So the book did happen quickly. This is what's happened with all of them because I go really deep. And then when I write, it actually doesn't take me that long because I have all the resources there. Like to me, the writing is the actual typing of the book is the last step. The writing is in the research. And I'm at the point now where there are too many holes in the mainstream cosmology for me to be able to believe it. And when I say cosmology, I think that's an important word because people often fixate on just the shape of the Earth, and they get stuck in this flat versus sphere or flat versus globe. And often those who are critiquing the flat idea don't even know what they're positing. They don't even know what the position is. And there's so much more to it because it's about also Earth's motion. And we get into things like gravity and Earth's magnetic field and a Big Bang. And what is the cosmos in totality? The shape of Earth is important, but it's part of a bigger picture. And the picture is one that I realized I never had asked from the beginning of my exploration. I was always asking, who are we? Why are we here? Why does life matter? Why am I going through all these struggles and ups and downs? But I never asked, what is here? I didn't ask that because I had this Big Bang model. And when I went to Princeton, I took a course in astrophysics and then another one in physics. And they taught us all about these things that I just took as fact. We're in this like massive expanding universe and this massive vacuum. And I never really thought to question the basics of that until exploring this book.
It's so funny. I'm taken back to the fact that at MIT, I was at MIT for undergrad, and my boyfriend for most of the years of my undergrad was a literal rocket scientist. It's like the ways, the tentacles of the assumptions that we make about this place that we live in and all of the plausible deniability, right? So like he was I knew a rocket scientist, right? Like obviously he was working on rockets or whatever he was doing. So they must be real, right? Like all of the leaps in logic that we make without actually being aware that we're making them are, I think, what insulate people who are confronted by the cognitive dissonance you're describing, right? Like you're looking at these colleagues that we have who have, come to this, you are now in a group. I wouldn't say it's small. It's a group of colleagues. And I mean, they're arguably the most free thinking, brilliant sources of reality testing and exploration that I have in this world, like are all in this group, right? And we all have come to this conclusion that's the basis of the group. And, you could have said, okay, well, I have these colleagues. They seem to be applying a similar lens to this subject of cosmology that none of us are actually expert in, but somehow they're interested in it, other than Steve, of course. And yet I have all of these pre-existing assumptions, right? I have all of these reasons to just like dig my heels in a bit more and, reject that whole path. And you didn't do that. You resolved the dissonance by going in as a novice. And I think that is, you have a lot of experience with that, right? You have experience with going from, let's say, expert to novice, like climbing the pole, sliding down, climbing the pole and sliding down. For many of us, our sense of self, the self-concept is too threatened. And I actually have connected that to a lot of father woundology where you need to assert dominance or mastery prematurely, honestly. And you don't have what I would refer to as a masculine capacity to fail well, that allows you to just start at the beginning again and to find your spine in the process. So you were able to do that and to really look at so many of these assumptions. But you reference, when you were talking about Steve Young's work, you reference, we could call it the replacement fallacy, whatever we want to call it, this idea that if you're going to challenge a sacred cow, if you're going to confront one of these assumptions, if you're going to disrupt the familiar terrain of a belief system, then you have to have a good replacement, right? If you're saying that we are not spinning around the sun, then how do you explain, the seasons or our diurnal rhythms? How do you explain this? And Dave does, I think, take that bait very well, where he has an entire app devoted to how do you explain and a lot of the theories of replacement. But that's not where I think you and I find the most fulfillment in the inquiry space, because gatekeeping falsehoods, gatekeeping disempowering myths, and really, holding as sacred the beliefs that keep us connected to our humanity, I think we share that interest. So I want to focus on that today, and I want to really give you the mic so that you can share with us some of the most powerfully influential things that you encountered, ideas that you encountered, facts that you explored that helped you to really loosen the grip that is societally supported on so many of these assumptions. And you mentioned things like gravity and the Big Bang. And of course, every time you question one of these things, it ripples forward, right? It has all these little babies of inquiry that get born once you deign to question one of these pillars of assumption. And you just resist the temptation to need a replacement immediately, right? And you just sit in the not knowing, which I think is a rather mature comportment towards, reality and the big questions that we have. So I'd love for you to share some of the highlights for the book. It goes without saying that this is a highly referenced and meticulously resourced text. It's actually quite concise, that this could have been, a 600-page book, and you did what I think a master does, which is you distilled it into something accessible when you could have made it into this huge flourish that I think a lot of us do when we're starting out with something, right? It's almost like that Shakespearean protesting too much kind of a thing. And you really narrowed it down in such a powerful, impactful way. And so that's why I thought if we give kind of the highlights of it, then people can know that they can turn to the book, find the references, explore on their own, go deeper in any one of these areas. But I'd love for this to be sort of a start here around the kind of questioning that you did for days on end in the period after you allowed for the cognitive dissonance to be resolved in this way.
Well, I will start with something that I don't hear people start with typically in the field of cosmology. And actually, the book starts with this, which is dark matter and dark energy. Interestingly, I started my first book in Upside Down Thinking talking about dark matter and dark energy. I said, look, 96% of the universe, according to mainstream physicists, is this mysterious stuff, dark matter and dark energy. We only know what 4% of the universe is. There's these big mysteries. What I didn't realize was the history behind this. And I'll give dark matter as the example, which is that in 1933, an astronomer named Fritz Zwicky was looking at this cluster of galaxies. And basically, the way the galaxies were moving did not match the predictions of mainstream physics. More specifically, it didn't match the predictions of Einstein's gravity, the general theory of relativity, which basically replaced Newton's gravity. And it wasn't just that the math was off by a little bit. It was off by the amount of missing mass was massive. There was under 1% of the mass that should have been there if Einstein's gravity were to be true. So instead of saying, well, maybe we need to question gravity and Einstein's relativity, we discovered dark matter. That was the conclusion. Dark matter was discovered. It was basically invented out of thin air because obviously we can't question Einstein's gravity. So there must be this missing matter that we don't fully understand. So that's problematic on the surface, but I want to read you just a few lines from an astrophysics professor, which he states very well in plain language. This is an IAI.TV article. His name's Pavel Krupa, an astrophysics professor at the University of Bonn. 2022 article. He says this: the current cosmological model only works by postulating the existence of dark matter, a substance that has never been detected, but that is supposed to constitute approximately 25% of all the universe. The other big portion is the dark energy. But a simple test, he says, suggests that dark matter does not, in fact, exist. If it did, we would expect lighter galaxies orbiting heavier ones to be slowed down by dark matter particles, but we detect no such slowdown. A host of other observational tests support the conclusion: dark matter is not there. The implications of this are nothing short of a revision of Einstein's theory of gravitation. So that's a pretty big deal right there, because I actually want to take you through the chain of events, just the very basics of it, because we started with Newton's gravity, and this was the idea that an apple falls to the ground because mass is attracting mass. So the mass of Earth is bigger than the mass of the apple, so the apple falls down. The problem is that Newton's theory of gravity is unable to predict certain things, like Mercury's motion around the sun in the sky. That's a big hole. So if you have a model that can't predict something, then it's not comprehensive. And that's been acknowledged. So Einstein's general theory of relativity came around, and that's supposed to fill in some of the holes. But apparently Einstein's theory of relativity is not working either, because we have to plug in this dark matter. So we end up with a cosmological house of cards, which is a very big thing because gravity is supposed to explain motion, and especially the motion of celestial bodies. And here, basically, something's not working. And that means we'd have to reconsider all of physics and all of cosmology. And to me, that opens the door then for everything to be reconsidered. And if you bring this on top of what we already know, and I remember this from studying at Princeton, there's no unifying theory of physics because the two leading theories are relativity theory from Einstein and quantum mechanics, but they cannot be combined properly. Basically, the equations explode. And I quote Michio Kaku in my book, who's a mainstream physicist, saying this is one of the biggest mismatches in history. And he talks about like how big the mismatch is. So basically on the surface, those who want to propagate the mainstream narrative of cosmology, I think they're in big trouble because we know it's extremely flawed. And because it's so flawed, we don't have a unifying theory. Gravity's got problems. Einstein's relativity has problems. And we're plugging in this dark matter and dark energy that might not even exist. It's fair game to question things. And I'll just pause there.
You talk about how there is a tendency to ignore these, I'll make up a word, these disproofs, right? To ignore what is clearly either unprovable or disproven. And there is a tendency to tolerate, all of this dissonance. Right. So, of course, I come at it from the psycho-emotional perspective because it's otherwise intellectually and academically inexplicable. But there is a consensus, right, that we find in medicine. You drew the same parallel, of course, that led me across this bridge. And the consensus that is operating in the cosmological realm recruits several different but familiar facets, right, from the academics and the sort of siloed experts in physics, all the way to, and perhaps we'll touch on this, to operations like NASA and the relationship to the media. So this concept, I find, now, of course, thanks to Steve and you and others, like I can't possibly use the new age language around quantum this, quantum that, and right. And all of the dark energy concept and dark matter and the invisibility of so much of what is meaningful in the human experience is parroted by yoga teachers these days, right? As being like something that we should, get excited about because energy matters. That's how I hear it translated. It's like energy matters. And the scientists have told us this. But, what I hear you saying as the first point is that the numbers only work in this model and the adjacent models when you fudge them, right? They only work when there's like a post hoc adjustment. And we can certainly do that, but let's not pretend that we've really exposed the nature of reality. Okay, so where do we go from there?
A logical fallacy that I think is so important, not just for cosmology, but for everything, and especially for cosmology. It's known as affirming the consequent. And the technical way of thinking about it is basically if X, then Y. Y is true, therefore X. Here's a simple example. If it rains, the grass is wet outside. I see that the grass is wet outside. Therefore, it rained. So the second statement is not accurate because there are many reasons the grass could have been wet. So just because the grass was wet, and we know that when it rains, the grass will be wet, doesn't mean that wet grass indicates that it rained. What if there was a sprinkler system on? What if a bunch of kids came by and threw buckets of water on the grass? We could come up with a million possibilities. And what happens in cosmology and medicine and so many other areas is that people get locked into a model of causality, of explaining why something happens. And then when they observe new things, they try to retrofit and force fit those observations into the model that they assume to be true. So here's an example with regard to cosmology. To me, this is a huge one because we can start with people like Einstein and Stephen Hawking and every major physicist. They will tell you that by observing the lights in the sky and the planetary motions, you cannot tell whether Earth is at the center, which is known as geocentrism, or whether the sun is at the center and Earth revolves around the sun, known as heliocentrism. The technical term is that they are kinematically equivalent when you look at the motion, that these two models are equivalent. So, but what we see happening is that people like to fit their observations into the heliocentric model, which I never thought to question because Copernicus had his revolution and then Galileo looked through his telescope and wow, we realized Earth is not at the center. But then looking back at what Galileo, quote unquote, proved in his telescope, how did he prove that we are in a heliocentric universe? And I will say his observations could be explained by heliocentrism, but actually they can be explained by geocentrism too. He observed the phases of Venus, which are sort of like the phases of the moon. And he said, okay, well, we must be revolving around the sun. But actually, if the planets move around the sun and the sun's moving around Earth, which is a model basically like Tycho Brahe's model from way back, then that would be geocentric at the core. Earth is at the center, and that could explain the phases of Venus. So that would be a geocentric explanation. And the same thing goes with his observations of Jupiter. He saw moons, basically smaller bodies revolving around Jupiter, smaller bodies revolving around larger ones. Oh, the Earth must be revolving around the sun, basically. Well, that's not necessarily true. You could explain the motions of things in the sky as maybe Earth is at the center and these other things are moving around. So those are just a few examples where people seem to get locked into a heliocentric cosmology. And often that seems to be tied to a philosophical preference. It's actually known as the Copernican principle. And there's a great documentary called The Principle that goes through this. The Copernican principle posits that we do not occupy a special place in the cosmos. And that's led many astronomers and physicists like Edwin Hubble, who came up with the expanding universe theory. He said it would be a horror, it would be intolerable if Earth occupied a special place. So he came up with the expanding universe because that would enable Earth not to have a special place while creating this whole other cosmology. So when you think about it in these terms, and you realize that like a lot of these things are not even questioned anymore, like the expanding universe, that's basic. Obviously, Earth revolves around the sun. Who really questions that? It's because these assumptions of causality haven't been examined, and they get so entrenched that many of the professionals either don't have the courage to explore them, or maybe they don't even think to question the assumptions.
So let's break down some of the basics, if you will, including that we are at the center, whatever that means, because you add some nuance to that. And it's typically referred to as geocentrism, and how you were compelled to believe that that's actually the case, having formerly believed that we were just on, a dead rock floating around, spinning at inconceivable rates around a sun. And then also, while it can be a bit of a straw man, this, flat versus round, whatever idea, the motion concept, I think, is like a bridge to then considering the fact that we're not actually on a circle with water sticking to the outside, right? So I sort of think of those as like a tripartite, and you break down each of these is in the book, but I think of those as like, you arrive at one, okay, yeah, that actually does make sense. You arrive at another, okay, yeah. And then you ultimately come to really just like shed these layers of conditioning, it's programming around the primary assumption that the solar system is what we're told it is, and that, we came from the Big Bang, and that gravity is playing this essential role in our day-to-day operations, and somehow explaining things like orbits and all of these otherwise inconceivable concepts that are totally unprovable by the average individual. So yeah, I wonder if you could sort of take us through a high-level view, like a bird's eye view of the science that helped you to understand these things differently.
And I like the way you put it, because it is different layers that then lead one, or at least in my case, it led me to then be able to think about the shape of Earth. If you just start there, it's a kind of a hard sell, especially if you've never been familiarized with the concepts. When you realize, okay, we've got problems with gravity. Okay, let's look at geocentrism and Earth's motion. Then the other things become possible. So starting with the idea of geocentrism, that Earth is at the center, or at least on the center of the axis of what we can observe. There is something called the cosmic microwave background. And I remember learning about this at Princeton. This is the background radiation that was supposed to have come from the Big Bang that proves that there was something that occurred 13.8 billion years ago, which if you really think about it, the scientists are trying to come up with all kinds of inferences about what happened that long ago in a faraway place and come up with this precise model. It's kind of ridiculous when you think about it. But they're basically sort of like with dark matter that had to be plugged in. There's this inflaton particle that no one's really figured out that apparently explains the early inflation of the Big Bang and the early universe. It's known as the reification fallacy, when you create an entity and then you speak about it as if it's real, even though it hasn't been formally established. And that's what happens with a lot of the stuff. But the cosmic microwave background, this is supposed to be the background radiation that can be detected based on the Big Bang. And there are a number of probes that have been able to measure this, and anyone can look it up online. The problem is that if Earth is not at the center, the prediction would be that the cosmic microwave background is homogeneous and it does not have a preferred direction. So it's isotropic, homogeneous and isotropic. That's the formal term. The problem is that it's not that. It's not homogeneous and it's anisotropic. It does seem to have a preferred direction. And mainstream cosmologists might say, well, these are just little anomalies. We don't need to worry about them. But it is so problematic, in fact, that some scientists have called this the axis of evil because it seems to point toward Earth, these little anomalies. And there are a number of other astronomical observations that I quote from various physicists who say, look, we observed this thing about the quasar and it points toward Earth. So it's pointing toward Earth having a central place. And along with this notion of geocentrism is the idea that Earth is stationary, that they often go hand in hand. And if you really think about it, if no one told us anything from mainstream science, would we believe that Earth is moving in the following ways? We are told that Earth moves in the following ways. That Earth is rotating on a tilted axis at 1,000 miles an hour roughly at the equator, which is faster than the speed of sound. But near the poles, it's almost no motion. We're also told that Earth has multiple wobbles and that Earth revolves around the sun, actually in a state of free fall at over 66,000 miles per hour, and that Earth is moving around the Milky Way galaxy at over 500,000 miles an hour, and it's expanding outward in this expanding universe, expanding into who knows what, but it's happening at over 1 million miles per hour. So everyone listening to this or watching this right now is moving in all of those ways, and yet we feel nothing. But there's an earthquake, we feel that. Or if we're moving in a car and there's any change in motion, if we accelerate or decelerate even a little bit, you feel that. You feel it on a plane if there's any change in motion. If there's a little bit of turbulence, you feel it. So the argument has to be that we're just in completely perfect motion and there's never, ever been any disturbance to it, and therefore we feel nothing. So this is not proof, but it should make one think for a second. Our senses would tell us that we live in a stationary place. And you look at bodies of water like certain lakes that are perfectly still, or surgeons that are performing very precise surgeries and they're not worrying about like Earth bumping a little bit. So it's interesting. Or rock towers where people build these things where like if there were any motion, the rock would fall, but they're able to build these towers. Many examples like that where it doesn't seem like we're actually moving, but the scientists tell us based on all their observations that we are. And then we move back to some of the key scientific findings that are still debated, but there's a study from 1887 called the Michelson-Morley experiment, which many people have since used to say that there does not exist an ether, which is known as the fifth element. And the quiet part that's not often stated is that Earth is moving. So the idea is that Earth is not moving through an ether under the conventional explanation. And I'm just paraphrasing. Another explanation, which many people are starting to question, including people like Robert Bennett, who's a PhD who wrote his physics thesis on relativity and comes from a lineage of people who actually studied with Einstein. So mainstream guy is challenging the interpretation. Another interpretation of the Michelson-Morley study is that the ether does exist and Earth is stationary. But the scientists have chosen one explanation, and then we built gravity and relativity and all these things, general relativity on the interpretation of Michelson-Morley, and also a study called Airy's failure from the 1800s, which those who believe in a stationary geocentric Earth would call Airy's success. So the interpretations of these studies are very important. And most of us who believe in a moving Earth don't realize that the basis of a lot of this stuff comes from so long ago. And I think that's a good just basis for questioning this stuff. And I will, before we move on, I do want to touch on the gravity topic, because I'm sure members of your audience are saying, wait, Mark, so like I know an apple falls to the ground because I can show you that. Again, we run into questions of causality. It's not that we're saying that an apple doesn't fall to the ground. It's what causes that to happen. Is it because mass is attracting mass? Is mass bending space-time like Einstein said? Or is there something else? And this is relevant to Earth's motion too, because all of these equations are based on the assumptions of gravity and relativity. And the leading theory that many people talk about, including Steve Young, theoretical physics PhD, is that first of all, there is density and buoyancy. So an apple's denser than the air around it, therefore it falls. And helium air is less dense than the air around it. Helium gas, so helium gas will rise. And then the question becomes, why does a denser thing fall down? Why is there this downward bias? And what many globe skeptics will say is that there's a downward electric current, which Richard Feynman talked about, and I quote him in my book, so a famous physicist that could explain this, and this would explain why there are many papers talking about changes in the rate at which things fall during thunderstorms, and also something called the Hutchinson effect, where there's a levitation of large objects using apparently electrical means. So there could be some other force that's not mass attracting mass that could explain all this stuff. So if we just pause there, wait, maybe Earth isn't moving, maybe there's actual science that suggests we've misinterpreted results, and maybe Earth is at the center, and these anomalies that physicists are finding could be easily explained if we move to geocentrism. Okay, wait a second, we're stationary, maybe, we're at the center. What else can be questioned.
Yeah. And if you zoom out, right, there seems to be a collective maturation and refinement of our understanding of complex systems, right? So if we think about the body as like gears and levers, you miss out all of the electromagnetism of the body and all of the vibrational medicine that becomes possible when you think about the body as a more complex system than just a bunch of buttons and levers like I learned in medical school, receptors and things plugging into receptors that have, of course, never been proven, actually. And, you are inviting us to consider the same thing with regard to this place that we live, right? So could it be that actually what, like the nature of this realm is more refined, it's more complex, and electromagnetism certainly allows for these simple explanations to be held in a more nuanced framework that doesn't require a lot of the uncomfortable management of these, the basic mathematics that just don't explain a lot. Or you have to go to these extraordinary efforts, like heroic efforts, to find your way back to explaining something that could very simply, like Occam's razor wise, be explained through, like you said, density, buoyancy, and electromagnetism. So another point that often comes up is, this idea of inertial frames, right? So like, oh, well, the reason you don't feel it is because, the air is moving along with the thing that you're moving on. And that's why you don't feel it, because it's like, relative to the other stuff that's moving. And, and again, I'm a doctor, not a physicist. However, I remember I had to take physics, in college. And I remember the concept of a closed system, right? That you need to have a lid on it, in order for it to be considered that kind of a frame. And there's so many ideas that you explore also in the book that just don't seem to work in a vacuum. Things like the propulsion of an engine on a rocket, in the vacuum of space, let alone all of these properties that we assign to our actual atmosphere that wouldn't ever be explicable if there wasn't a lid, right? So obviously most of us refer to that as the firmament, and it helps us to make sense out of a lot of the phenomenological observations that we make. But we are, right, in an open system, right? It just goes from the grass in my yard to this infinite expanding void of nothingness. And I've just come to wonder, like, how is it that academic physicists make sense out of that? Because I guess that's when you invoke gravity, right? Because you need a magical concept to really rationalize these otherwise inexplicable things, right?
I think it becomes very far-fetched when we think about this idea of an open pressure system that's sitting next to a near infinite vacuum of space. And by vacuum, I mean an extremely low pressure system. So the example that's often given to explain this is if you open a can of soda, inside the soda before you open it up, there's a lot of pressure from the gases. And when you open the can of soda, you hear a loud noise because the air around the soda can has less pressure than the gases in the can. So the loud noise is basically the reaching of equilibrium of the gases going out of the high pressure system in the can outside into the air around it. And that's what happens in nature, is that there's this equilibrium that's reached. So if what's happening on Earth is true based on the current cosmological model, we're told, then there's this extremely low pressure system, infinite vacuum that's expanding and getting bigger and bigger of almost no pressure, sitting next to clearly some kind of a pressurized system on Earth, our atmosphere, but there's nothing enclosing it. So they're just sitting peacefully next to each other when you'd expect, because of this, it's a large gradient, the differential between the pressure of our atmosphere that's holding everything in versus the low pressure vacuum of space, that our atmosphere should just rush out into space without a container being there. But we're told no, that gravity, even though it's really a weak force most of the time, especially at the high altitudes when it's far away from the center of mass of Earth, somehow gravity is holding everything in. It sounds again like a rationalization, whereas it's much more parsimonious, or using Occam's razor, simpler to say, well, maybe the whole idea of a vacuum of space isn't true, and maybe there is some kind of enclosure.
So people love to ask me questions, and I love to ask questions of others because inquiry is play. But some of my interviews and answers are too hot to handle for Reclamation Radio. So in my membership Vital Life project, I have created a private podcast that gets delivered to wherever you listen to podcasts, where I answer your questions that arise because of my provocative subject matter. And I also share interviews that might otherwise be censored that I call the Sovereignty Series. So you'll get access to these private podcasts and a private chat by joining my membership Vital Life project. Let's move on to this shape concept. So you bring up a lot of amazing points in the book, including how far we can see, beyond the curvature, the ideas of a curvature as accounted for or not by engineering and navigation. And then, you talk about things like time zones and lunar eclipses. Obviously, this is just meant to be sort of like a hors d'oeuvre. However, I love all of these topics because I really spend a lot of time on these because, as you mentioned, it's almost like the glittery object. It's like, well, what is the shape then? If we're not in a ball, what is going on? And a lot of folks have spent a lot of time on this. You reference a bunch of these folks like Austin Whitsitt in the book itself. But I wonder if you could give us your high level understanding now of the skepticism, that you've brought to bear when it comes to the globe shape itself.
Yes. And to reiterate, what I'm doing here is summarizing what many other people before me have done. And I cite them. So Austin Whitsitt, Dave Weiss, many others have created resources on this. But there are some very interesting examples which to me challenge the model that we have been told. And the model is very specific, which is that Earth is spherically shaped. It's technically an oblate spheroid because it bulges a little bit at the equator, but basically a ball that has a radius value of roughly 4,000 miles. So if we find things that contradict that, then we run into problems for the current cosmology. And like you mentioned, Kelly, the ability to see things that should be blocked by the physical curvature of Earth, that would invalidate seemingly the radius value of Earth, meaning it would invalidate what we're told about the sphere. And there are many examples of people going out and sometimes you don't even need telescope or binoculars, depending on your altitude. So there are all kinds of equations you'd have to look at very carefully, but depending on what your elevation is, whether or not you can see things. This would sort of be like trying to see something that's around a bend if the bend were there, i.e. if the curvature of Earth were there. You wouldn't be able to see it because you'd actually be blocked by the mass of Earth. And yet repeatedly people can see things. And what the mainstream answer to this is, it's refraction. So what you're seeing is a mirage. It's not actually there. The light is bending so that it looks like it's there. And one of the most famous examples is being able to see the Chicago skyline from a distance away that wouldn't make sense. And this was all in the news. And the answer from the mainstream is, yeah, this was a mirage that you're seeing. But that's just one example out of many that people have looked at. And what was compelling to me was that when I would have expected the agencies to just show example after example of, look, this should be blocked by Earth's curvature and you can't see it. Like many, many examples of that, just proving that you can't see things, but actually the reverse seems to be true. People go out on their own and they're able to see things. But that's not it. I mean, if that were it, I don't think I could have written a book, but there are many other reasons to ask questions. You mentioned time zones. And also I want to put this together with magnetic declination, because to me, these were super powerful examples. Magnetic declination is basically the idea that Earth's magnetic poles do not match the geographic poles on the spherical model. So there's a geographic location that we call the North Pole, but the magnetic north isn't there. And the magnetic south isn't at the geographic South Pole. And actually these magnetic poles are moving around for reasons that are not well understood. And we're told that the magnetic field of Earth comes from the core of Earth. Problem is we've never been to the core. And actually the farthest anyone's ever been able to dig down is under 8 miles. And the radius is roughly 4,000. So we've barely gone down at all to be able to know what's below us. I mean, ideally, if we had the technology, we'd want to dig all the way down through the core and then out the other side into space to prove a sphere. That would be one way to do it. We've only been able to dig down under 8 miles. So the idea of a core is completely theoretical. And by the way, when they were digging down almost 8 miles, there were many mistakes and many things they didn't predict based on whatever assumptions were there. So who knows what's actually at the core? But the idea, even though we've never been to the core or haven't proved it, that the outer part of the core spins in a way that generates the magnetic field. And it has to do with Earth's tilt. It's known as the geodynamo theory. The problem is no one's ever replicated a geodynamo theory. So the whole notion of Earth's magnetic field is based on all sorts of assumptions that haven't been validated. Now, where this becomes very practical and sort of hooked me is that this affects our navigation. So people who need to get to a geographic location, you need a compass. The problem is that you have to adjust your compass. And there's a website anyone can go to, magnetic-declination.com, that shows you basically the amount of adjustment that you would need at different geographic locations. What's most interesting to me about this is that things go haywire in Antarctica, below the 60th south latitude in particular, which coincidentally is where the Antarctic Treaty starts to restrict travel. Since 1959, governments around the world have made it basically impossible to have free and private exploration of all of Antarctica. Certainly you can go to little parts of it, but saying you went to San Francisco doesn't mean you saw all of North America. Like, we need to have free and private exploration of everything. And they say there are environmental restrictions and so forth. But south of the 60th south latitude, we see the magnetic declinations at sometimes like over 170 degrees. In other words, if your compass is telling you one thing, you need to turn around if you want to get to the right location. And then a few miles away, it's like positive 50 degrees. And then a little bit away, it's like negative 30 something. And anyone can go and check this out. But if you were to take a plane of Earth, so instead of flat, let's say Earth is a topographical plane, meaning it has peaks and valleys, mountains and valleys, but it's a plane. If you were to try to wrap that around a sphere, you would end up having to really compress what is Antarctica on the sphere. Okay, so let me just also explain this. The conventional way people think about this topographical plane of flat Earth, the leading theory is that Earth is actually a circle. So it's round in a circular sense, not in a spherical sense, which is important. But if you took everything you saw on a globe, put it into a circular lake, and around the side of it is an ice wall that contains the lake, that ice wall is Antarctica. So under the flat framework, Antarctica is not a continent, but rather it's an ice wall. And in order to prove this, we would need to be able to explore it, which we can't do fully. So there are things that remain theoretical. But if you took that general idea as what's generally true, and you tried to wrap it around a sphere, you would end up having to compress Antarctica significantly into this continent at the bottom. So that would explain, that's interesting. That's why it goes haywire. And also interestingly, at the equator, which is where the flat and the spherical models are closest, that's where there's the least amount of magnetic declination adjustment for navigation. So that's interesting. Time zones are kind of similar in this regard, because it would be really, really simple to just come up with 24 time zones, 24 hours in a day. And yet we have 24 time zones at the equator, but in the northern hemisphere, it's 19 time zones, and in the southern hemisphere, it's 32. So you end up with a very similar thing, where at the equator, the flat and the spherical actually seem to align much more. But when you go outside of that, things go haywire, especially in the southern hemisphere, where basically time zones seem to be hidden in the ocean randomly. And the skeptics of what I'm saying, they'll say this is just all, there are political reasons for it. But one might wonder, is the true shape of Earth being hidden by this sort of thing? And I'll just give one more example before pausing. There is a type of eclipse called a Selenelian lunar eclipse, where the eclipsed moon and the sun are both visible at the same time, which would not make sense under the globe model, because Earth is supposed to be getting in the way and casting a shadow. So the argument for mainstream cosmology, again, is refraction. You are seeing an illusion when you see that. And I even quoted a scientific website, and they were like, yeah, the Selenelian eclipse, it seems impossible, but arguably it is impossible unless you invoke this magical refraction, where maybe something else is happening. Maybe it's not the globe of Earth that's causing the eclipse.
And a lot of what you're referencing, including the way that engineers build bridges and, railroad tracks are laid down on the Earth. You're referencing the fact that if we look at a planar map, it makes sense. That's like easily accessed. And this is also true with like emergency flight landings, right? There's people who've written books and collected flight paths to illustrate that these emergency landings are done in ways that make total sense on a plane, and make plane plane. And well, wait a minute, that's exactly the same spelling. You know what I'm saying? Like on a flat, but it ends up being a distraction to use that word. So I like to use the word plane anyway. That make total sense in that model, and make literally no sense at all in the model that wraps it around a ball, as you're describing, wraps that map around a ball. And so a lot of the confusion and the inconsistency that you're referencing is when you are insisting that it is on a ball, it doesn't work, right? So when you're saying you need to turn the compass around, that's based on your assumptions that you would only make if you're assuming that it's this landmass at the bottom of the globe, right?
Exactly. It's so deeply ingrained that people don't ask, well, maybe we've just gotten it wrong about where we live. Oh, no, we just have to adjust our compasses in order to get to the right place. That's just what you do.
Right. Right. And so this phenomenon is what we see becomes necessary when we need to kind of dance around our assumptions. So I want to touch on one other subject, Mark, before we wrap up, because this could be a whole, weekend workshop, obviously, but which is the subject of NASA. Because you deconstruct a lot about, and it ends up for whatever reason, I find this very entertaining. And it's so much better looking at videos and stuff of footage and bloopers. And are you kidding me? Like, we are meant to believe this. But if you don't take the time, which of course most of us don't, right? Like, I never did. I never even thought twice about it. And like I said, I dated a rocket scientist in college. Then you might not see the sort of potential pyramid scheme that is the organization itself, and the sort of almost mockery in plain sight that is the presumption that any of this is real, even if it is gatekept by just a few individuals. Like, of course it's real. And I even, you think about like almost like the childlike wonder that some people experience as contrasted to the adult empowerment of a geocentric cosmology, the childlike wonder that folks experience when they like look at pictures of the planets, that are CGI rendered, and it just, I don't know if it's like from the mobiles that hung over our cribs, or the pictures in our kindergarten classrooms, or what is it? But I can feel that almost childlike state that is meant to be induced by the invocation of the artwork and the visuals associated with NASA propaganda relative to, what some have come to understand is more likely to be provable by the average individual, right? So things that you can go out, you can see how far you can see, you can sense what your body is sensing, you can, track so many aspects of what is actually going on in our lived experience, and you don't need to, reference some, acronym agency to have an understanding of what's going on. The same way you don't need to do so with, the medical system either. It's your body, you can know it. So yeah, there's so much to say about NASA, but I wonder, if you could speak quickly or not quickly, speak how long you want, to the conclusions that you've come to around NASA that surprised you, maybe, relative to what you used to believe.
In some ways, this was the hardest thing for me, because we've just seen so much about space from NASA, and we've visually seen it. And to think that it's all a lie, it's really hard. And actually, I put this at chapter 6 of the book, because if we think about it from the perspective of, let's say, from the 1940s, before there was this kind of space exploration, it would be much easier to challenge the current cosmology. But since NASA and other space agencies, the visual information then implies massive conspiracy, which I know many people don't like to do. With the other stuff, we could say, oh, they just messed up the science and they had too much ego and they were affirming the consequent. But when you start to talk about space agencies, there has to be deception. There's no way around it. And intentional deception. And that doesn't mean every single person at the agency knows. You could have people who are innocently following along. They're taking in data that they don't know has been forged or whatever it is, or they're coming to conclusions just because of their assumptions. But there has to be something or someone, at least a few, that are perpetrating something. I start the chapter off quoting Igor Volk, who is a Russian cosmonaut, a famous one, who said, "We never went to space." He was interviewed, I believe it was in 2014, by a Bulgarian journalist, who that Bulgarian journalist years later validated again that that's what he was told by this Russian cosmonaut. So that's pretty interesting. Also, the moon landing telemetry tapes. So this would be the data from the missions. They're gone, aside from a few canisters of one of the missions. And I quote a NASA document that says they're gone. That to me is outrageous for such a remarkable achievement of humanity, for the data to be gone. That's interesting. And also, I would guess members of your audience who are new to this, they're probably saying, well, I've seen pictures that show curvature. So what do you mean? Like, so you think all the pictures are fake? Number one, I think any picture we see, look at the fine print, because often it says this is CGI, meaning computer generated, or it's a composite. It's put together from many images, or it's an artist's rendition. And you can go on NASA's website. I mentioned one. It was an artist's rendition of something from Jupiter, for example. And one of the classic images, the blue marble image, which is on all the iPhones, or one of the early iPhones, this was photoshopped, admittedly, by a NASA artist. And he was interviewed about this, and he basically talked about how he made something that he thought would be like Earth. But the last image we supposedly have that has not CGI or photoshopped or altered in any way comes from 1972 from the moon, allegedly. But even that is a disk that we see. We see a circle. Really, if we wanted to prove Earth as a sphere, Kelly, what would we do? We would have a camera out in space that shows the full sphere in continuous footage doing a full rotation. And it would show us the things that we're told to believe that sound kind of crazy, like buildings on the top standing upright and buildings on the bottom of Earth hanging upside down, and then buildings on the side hanging sideways all at once. We'd want to see that continuous footage. We don't have that. We'd also want to see Earth in its place, allegedly, in the solar system in the correct order with the sun at the center and everything else. We don't have that. What do we have? We have these images of a disk or these sort of blurry images from the moon, and we have lots of renderings. But then we do have some images that look like they're showing curvature, like from the ISS or the Felix Baumgartner, who went up in like a Red Bull test, and apparently it showed the curvature of Earth. Problem is, he was using a fisheye lens. So the lens that's used has to be examined always. And we never have the full picture. And I want to emphasize this too, because some people, I had someone say this the other day, like, I go up in a plane, Mark, and I see curvature. What do you mean? Like, how could you even entertain this idea? There's a distinction between the appearance of circular curvature versus spherical curvature. Spherical means it's curving down and away in every direction, because apparently we're always at the top of the sphere. That's what the model would predict. And so as we get to certain altitudes, and we can do the math on what the curvature would be, it would be bending down and away. And also the horizon, as we ascend, should be going down and away more and more, but actually it always rises to eye level, which is interesting. We don't see that. But on a plane, you might, or even on the ground, might look like you're seeing in a dome. And this has to do with visual perspective, which is a much longer conversation. Basically, the way that we see things that are in the distance, it looks like they're going down. So we end up with a personalized, it's called an azimuthal grid of vision, which shows us the appearance of a personalized dome where it's circular, but it's not spherical. So that's a point of confusion that many people should consider. And then the last thing before I pause on NASA is the ISS, because I get asked about this all the time. It was really hard for me, but I'm watching video after video of something falling while another thing is floating at the same time. And even a video I mentioned in the book of an astronaut saying, yeah, sometimes we hit these gravity pockets. So he's got a hammer floating because it's zero gravity, allegedly. And he holds a playing card and just drops it and it falls straight down. So even though you have this ISS that's going thousands of miles an hour, he somehow knew there was a gravity pocket in that one place at the time he was doing it and was able to drop a card and it fell straight down and the hammer's still floating at the same time. There are many examples like that. And to me, if there's any instance of fraud, you have to question how can you trust anything if it's that bad?
Not to mention, what is the figure of the amount of money going to fund NASA every day? It's like something.
It's ridiculous, like millions a day.
It's like 100 million a day or something. Oh, the antics. So the subtitle of your book, Mark, to wrap up, is Rethinking the Big Bang, Heliocentrism, the Lights in the Sky, and Where We Live. So if you could put it in a nutshell, what do you believe at this point?
Yeah, it's a great question, because the book, I try to take the most conservative route possible. And like you said, I tried to design a book that you could hand to anyone and really just start from the basics. So it was more focused on disproving the current theory. So I would say that I don't think there was a Big Bang 13.8 billion years ago that we're told happened. I don't think we live in a heliocentric universe. I think geocentrism or something like it is much more likely. I think the lights in the sky that we see, meaning the stars, the planets, are much closer than we've been told. Even the sun, we're told the sun's 93 million miles away and the moon is 238,000 miles away. And when there's an eclipse, it just so happens that their sizes and distances match so that they're like the exact same size and you have one eclipsing the other. I think they're probably much closer in size and much closer to us. But I do have a lot of questions about what the lights in the sky are. I do think there are lights and things happening up there. I just don't fully know what they are, and we really can't test that. And the last part is and where we live. I used to think that we were on a ball floating in space, which is kind of, when you think about it, and like free falling around the sun, but we don't feel it. I don't think that's true. I do think there are many observations, so like some of the ones we talked about, and also things like horizontal wave propagation, when waves go out in a horizontal manner, but they somehow reach another portion of the curve. And there are all kinds of ways that's explained, or the ways that whales can communicate allegedly around a curve using sonar waves. And somehow like the waves are bending around the curve. There are very weird things that would be much easier to explain if we said that we lived on a plane. So I think there are many observations that fit that. But I also have questions just metaphysically because I don't really know what matter is. And there are a lot of things that aren't being explored because the funding is not going towards it. And we're so stuck in the heliocentric spherical model that we're unable to test things that would be nice to test. But if matter isn't as solid as we think it is, then I do think reality is malleable in some sense, which raises all sorts of questions about like, can we trust that the way something was 10 years ago, is it that way now? Like, do things change over time? Do things change based on our consciousness? And it leaves me in a place of feeling like I really don't have a good sense of what this place is. And going back to what I said at the very beginning of like, I never asked the question, what does it mean to be here? Like, where do we live? It ties into the bigger metaphysical questions because where we live might inform why we're here. And I feel in many ways more confused than ever about it. Like, I just don't know what this place is. What's the real history? I have big questions about that. I don't think the history books are correct, but I don't know what the correct history is. And it's like, how could we collectively be in such a state of ignorance to get it so far wrong in so many areas, not just cosmology and medicine, everywhere else? It just points to me, I mentioned this in the book, that we're in some kind of a spiritual war where I think there are dark forces that are keeping us in a place of ignorance and then using very good people who believe the assumptions and then propagate the ignorance.
Yeah, perhaps so that we can claim our innate knowledge for ourselves, right? So perhaps it is all still by design, that cloaking of our inner knowing and the reveal. It is quite delightful, I think. And I just, as you were speaking, I got this ping. I was like, oh, his next book is going to be about history because that's another one that's very needed. I'm just going to have your little library on my shelf for my kids to probably never read. No, they intuit a lot of this stuff and they don't need the same pedagogy that, people in my generation anyway seem to need a lot of defragging of the programming. It's really pretty extraordinary to bear witness to. So last thing I promised, is there something that you would say to your former thinking self, right? So maybe even like 6 months ago, right? Or whatever, like a year ago, when you feel into the like, who cares? Fuck that. This is, wrong or uninteresting, or like, that's a psyop, or, some sort of wayward conspiracy theory, like people taking questioning too far. Like, is there something you would say to yourself about this transition, right? Because what we talked about today, we really showcased what a revolution in personal belief looks like, right? And what the anatomy of it is, like how it is that you find these little ruptures and you allow them to unravel. I like the analogy of like, it's like, the movie screen has a tear in it and you think like, oh, it's not a big deal. Like I'll just tape it up. It's fine. And then it just keeps tearing. And eventually you can't watch the fucking movie. Like the show's over, right? You got to get up, realize you were in a movie, walk out, decide what you're going to do with your afternoon. And so that process requires a maturational fortitude that is certainly not for everyone. It's probably not even compelling for everyone, let alone available. And I wonder if there's something you might like whisper to your former self to invite this inquiry.
I would say that it comes down to challenging assumptions and asking myself, why is it that I believe this thing to be true very deeply? And if someone told me it's true, or they pointed me to a scientific paper, what are the assumptions baked into that? So that's what I've had to do more and more, is challenge all the assumptions. But as I got into the cosmology topic, it really was not as disorienting for me as some of the other ones. It's sort of like, okay, here's another one. I mean, everything else I thought was true is not. And it was basically a bigger version of the medical paradigm that I was exploring, of the germ theory of seeing false or conclusions that were unwarranted. But it was on a bigger scale because now it's physics and the Big Bang and shape of Earth and gravity. It's like a million different things. But when you actually take the time to go through each one, it's all there, and there isn't a compelling counterargument. And now my book's been out for, I don't know, several weeks, and I still haven't heard a compelling counterargument or a compelling experiment or set of experiments that definitively prove the current cosmology. Like, give me an example that shows for sure Earth is spherically shaped and moving in all these different directions. And give me an example that can't be explained by something else. Because certainly the globe model can explain a number of phenomena, but that doesn't mean that it is the correct model. In the same way, the grass is wet doesn't mean that it rained and that's the reason why. So to me, it's like this exercise on a bigger scale that I would have whispered to myself. But I was open to this. So I would just maybe go to myself 8 years ago before I started exploring all these things, where maybe there was a part of me that knew something was off, but I was just so focused on my life the way it was. And I was on the treadmill and I was going to keep trying to achieve because I thought science told us something and I had never explored it. So maybe what I would have whispered to myself back then or even earlier was start looking into these assumptions that you've been told about why you exist and what Earth is and how society works. Start exploring it in your free time, just a little bit. And I think if I had done that, I probably would have been open, but I was so focused on other things.
Amazing. Scientism is a powerful field. Yeah. When we really see it for what it is, which is a religious orientation, right? So the book is called An End to the Upside Down Cosmos. I am so delighted to have you among the ranks and really enjoyed just bearing peripheral witness to your process and the integrity with which you approach just about anything you intend to explore. It's really, really refreshing. And I can't wait to see what you have next. We'll make sure that the links are in the show notes. And I want to thank you, Mark.
Thank you so much, Kelly. And thank you for your open-mindedness too.